Assalamualaikum warahmatullahi wabarakatuh and hi. My name is Iman Rakim Mirosdan. I will present my final year project proposal presentation, and this is my topic: vibration cancellation of double-link flexible robotic arm manipulator using PID controller tuned by Grey Wolf Optimizer. So this is my personal background. My name is Iman Rakim Mirosdan and I'm from UiTM Shah Alam, and this is my context, and my supervisor is technologist Dr. Muhammad Sukri bin Hadi. These are the content that I will cover in my presentation, from project summary, background study, literature review, until references. Okay, so what is my project summary? The majority of today's industries are significantly impacted by the multi-link manipulator. The multi-link manipulator motion control has proven to be difficult, especially when flexible structure is being used. Because of the complexity of their structure, excessive vibration cause the system to be failure. In order to maintain the system lifespan, this project aims to reduce the system vibrations. So the goal can be accomplished by creating an intelligence controller for a double flexible robotics manipulator DFLRM that uses a proportional integral derivative PID controller and is tuned by a Grey Wolf optimizer GWO. Through evaluation and simulation, which is we are in my research, I will be using MATLAB and Simulink. So the conventional method, which using the PID-ZN, it is called PID Ziegler-Nichols, and intelligent method PID GWO, PID Grey Wolf Optimizer will be used to compare which is more efficient to suppress the excessive endpoint vibration of DLFRM through simulation using MATLAB or Simulink. The result is expected that the GWO is successful in following the desired hub angle with low rise time, settling time, overshoot, and steady state error. Also, it is effectively suppresses the endpoint acceleration at the first mode of vibration. Thus, GWO is used to tune the PID controller to suppress the excessive vibration at DFLRM. Example of doubling flexible robotic manipulators. On the left side is the 2D drawings, and the right side is the actual life, the actual robotic manipulators that used in automotive industries. It is used to handle and lift the body of the cars like heavy, that various loads. Background of the study: robotic manipulator arm is multipurpose mechanical device that used to move tools, parts, or materials. Because of the performance of robotic arm manipulators is highly dependent on geometric parameters, critical to optimize them in order to achieve desired function. However, it must have drawbacks, such as it must constantly be monitored to ensure the robot not develop any mechanical faults. PID controller is introduced to improve the system stability. Optimization algorithms used has been demonstrated to produce desired response for the system. Thus, Swarm Intelligent Optimization Algorithm (GWO), which is Grey Wolf Optimizer, is introduced into the system to tune the PID controller. So, we proceed to the literature review that I've made from previous researchers. Industrial demand for higher efficiency and lower consumption of robotic technology for past 10 years. Previous studies looked into the particle swarm optimization, which is PSO algorithm based decentralized intelligent PID controller for DLFRM. Simulation experiments tested using DLFRM test rig revealed that PID tuning by PSO leads to the good results. So, coupling between rigid and flexible dynamics of link could cause stability issues. Thus, to reduce unwelcome vibration that system generates, active vibration control must be developed. AVC must be developed to reduce the unwelcome vibration of the system. AVC main objective is to quickly and efficiently suppress an extreme vibration on the system. As a good example, a researcher, Yang and his colleagues, in 2019, they established AVC for low frequency vibrations in ultra precision machining to enhance the functionality for machine tool. The desired outcome was achieved using ABC strategy based on the infinite and zero stiffness mixing, which suppressed the low frequency resonance in their study. Control scheme is required to sustain all the weaknesses at the LFRM, decentralized control scheme. The technology of decentralized control (DDC) was introduced at the end of 1980s. Okay. Consequently, optimization method is proposed and implemented in order to optimize the decentralized control scheme so that it could improve the results and boost the LFRM performance efficiency. Next, optimization approach is primarily used to solve a variety of technical problems, including control system design in order to enhance system performance. As a good example, I've made a research regarding the Karam et al. In 2017. He tuned the purpose function of PID controller for single-link flexible robotic manipulator by applying bacterial foraging algorithm to the system. Even the payload varies, system effectively lessens the impact of vibration and reduces it to zero at the tip of the link. Besides that, to achieve desired results, optimization is therefore better when combined with controller. As a good example, Grey Wolf optimization. Grey Wolf optimizer (GWO) is well-known optimized algorithm. Then Chen in 2016 he used a PID controller strategy that relies on GWO to control characteristics of variable air volume (VAV) of air conditioning system. Through this simulation, MATLAB or Simulink, this PID control technique improves system performance, which is it leads to the desired outcomes. Okay, what is the problem statement in my research? Finding a good control algorithm to keep the DLFRM in precise positioning is very, very difficult. The need for manipulators with higher performance has given rise a dynamic which the flexible is crucial part. The AVC alone cannot achieve the best result. Therefore, suitable evolutionary computing technique required to optimize the decentralized PID controller to provide the best performance for complex and nonlinear systems in order to suppress unwanted vibration. My project objective is to simulate the PID controller's parameters tuned by GWO through MATLAB or Simulink that is used to control DLFRM to desired angle of both links and to reduce excessive endpoint vibration, and also to evaluate and compare the performance between PID GWO with PID ZN in controlling the hub angle and endpoint vibration of DLFRM. Scope of work: rigid link movements only take input tracking into account, while flexible link movement is evaluated. The robustness of developed PID controller will be assessed based on various disturbances, which is single disturbance and multiple disturbance. Limitation is the first one is due to the short amount of time allocated, which is 2 semesters. Project only can be done through simulation, which is I will be using MATLAB or Simulink. And the other one is model system is used from previous researchers, such as the doubling flexible robotic manipulators model system. So the methodology, I'll be start by doing the literature review regarding my topic, and then start to develop PID controller for doubling flexible robotic manipulators. And then there are 2 types of PID based controller, which is the conventional and the intelligent. The conventional is PID Ziegler-Nichols, PID ZN, and the other one is PID GWO, PID Grey Wolf optimizer. Then these methods undergo analysis and comparative study using different disturbances, which is single and multiple disturbances. And then the expected outcome is PID GWO achieve the lowest mean square error in the system and effectively suppress the vibration. So this is an example of the closed loop systems block diagram for hub angles 1 and 2, and closed loop systems block diagram for endpoint acceleration 1 and 2. Expected result is, while PID controller tuned by Ziegler-Nichols scheme is fluctuating over time, the PID GWO is expected to match the target output, and the results of PID GWO controller is expected to achieve lower rise time, steady state error, and overshoot values from PID ZN. Thus, this will demonstrate that PID-GWA is more effective at reducing vibration of DLFRM than the conventional controller PID. And these are the references that I used for my research. There are 15 for my proposal FYP. And that's all for me. Thank you.